Oops. So, hello everyone. Let's start our session. You can hear me, right?
Yes.
Yes.
Okay, sorry for the slight delay. Okay, so we can start with the first presenter. The paper is titled Development of a Strategy for Duplication Search Based on Multiple Hierarchically Organized Approach. Who's going to present? There are a lot of authors available.
Yeah, I'll be presenting that.
Okay, thank you, Leonardo. You can share your screen and start your presentation.
Okay. 1 second. Are you able to see the presentation?
Yes, we
Okay.
can see the presentation.
Hi, so I'm Leonardo Mello, and I'll be presenting the development of a strategy for duplication search based on multiple hierarchically organized approaches. So basically, when we are dealing with especially large databases for corporate, in the corporate context, duplicate records occur very often. So that may occur due to many sources of information, so many systems using the same databases or things like that. There's many reasons for that to happen, and that can distort analysis, harm customer relationships, and increase costs. So it's a very serious problem and very common. And traditional deduplication methods often use isolated approaches. So either a rule-based method or machine learning techniques. So a rule-based method is very fast and easily interpretable. So it can be a very simple rule. For example, if the bureau number of this customer is the same as this other one, they are the same. So it can be very fast and very simple and interpretable. And they can be a little bit more complex, but they can't deal with semantic analysis or complex cases. So that's where machine learning enters the picture. So it offers greater flexibility, but it has a very high computational cost. So you are able to make semantic analysis, but the computational cost is way higher. So yeah, so we propose a hierarchically organized engine based on multiple approaches. So the proposed approach is a modular engine designed to identify duplicated records operating as a service, accessible via an API and a user interface. So we have multiple sources of the data. So we're dealing with customer subsets here, and we have the main engine and also a UI for that engine. And we store that all the comparisons and the process data because it's a slow process, so it needs to be asynchronous. And we also have connection to a LLM model. And let's have a look at the architecture. So the engine performs sequential rule-based comparisons and integrates with an external LLM service when advanced client comparisons are required. So it will only use the LLM service if it identifies a complex case. And it stores the comparisons, and it has the three main modules. So expert rules, those are the hard rules, and textual similarity, and LLM-based comparison. So the first layer, that's the expert rules layer. So we have, in this case, 4 rules as an example. So we use those on the experiment. So system ID rule. So if the system ID is the same, and bureau info rule, so information about the bureau for that company, for those companies, if it's identical, and identification context rule. So this is a more complex one, but it's just the aggregation of multiple data points for those customers, and the fourth one as well. So if any of these 4 rules identifies a correct match, so they just return as a positive, and it doesn't go to the layers below. And the second layer uses cosine similarity for syntactic and semantic analysis. So it's textual similarity, and but not just syntactic. So the cosine similarity has this capability of also doing quasi semantic analysis as well. But it's also fast, so it's not as slow as a LLM. And the third layer uses LLMs for complex duplication cases. So the second layer, as I explained, all client data is merged and into a single string per client. So here, the string data, and the embeddings are generated with an autoencoder model specialized in short texts. And there is processed as embeddings, and then the cosine distance is calculated and normalized 0 to 1, indicating similarity. So for example, for these 2 customers, we'll have this string data and then autoencoded and this cosine similarity. So we use this to base if it's a positive or a negative match. And then the LLM layer is used as a last resort. So it has a very high computational cost. So we use it for complex duplication cases, and it sends structured client data with a broad comparison prompt, and the model returns a duplication decision with a brief explanation. So it also has this power of giving a semantic explanation for why it was a match for those complex cases. And so it adds a lot of value in this way. And the optimization it's only invoked when data is not clearly different. So when the second layer doesn't find a match, but also is not positive that it's not a match, it will go to the LLM layer as an optimization. And okay, the data flow starts at we are always comparing pairs of clients. So we go through the first layer, then second layer using cosine metric, and then the third layer. And we always, if we find a clear match for any rule, we always return, and that's a positive. And but we always go through all 4 rules of the first layer if it doesn't find a match that it's equal, but it can also return on the general similarity rule if it doesn't find a match as well. If it's really different, it will not go to the third layer. So general advantage about this engine is that it maps business-specific duplication patterns as the expect rules. It also reduces false positives and negatives, aggregating the power of all different strategies. And it minimizes computational costs by scaling only complex cases to LLMs. It also enhances adaptability across simple and complex scenarios. So our methodology for testing this, the efficiency of the engine, was a synthetic customer data set. And we had 2 sets of 100 customers with duplications between them. And basically this generates 10,000 pairs to compare. And the engine configuration, we have 4. So only expect rules, so only the first layer. only similarity layer, so the cosine similarity, only LLM, and then the complete engine with those heuristics as well. So as a result, we achieved this. So in my opinion, the most important part are the true positives and false positives. So the expert engine, only with expert rules, found 20 duplicates that were really duplicates, and no false positives. So the expert rules are good in this sense. And the similarity engine found 23 positives, so it found more positives than the expert engine, but it also found a lot of false positives. So yeah, the similarity one has this drawback. And then the LLM engine found 40 true positives. We had 50. I didn't say that, but we have 50 duplications, and it found 40 duplications, but also 6 false positives. And the complete engine found 48 true positives of 50 and only 2 false positives. And so the complete engine really is a sum of those parts, and really multiplies this the capability of each different rule. So here we have a more detailed approach. So the scenarios that we run the tests through, so only expect rules. So those are the duplications that we manually inserted into the data. So we had 20 expect rules, duplications, 20 general similarity, and 10 complex similarity. So a similarity that is not simply textually based, and the general similarity are closely related to text, but are not directly approachable by expect rules. So we had this as a result. So yes, pretty good results for our complete engines, having a 96% hit rate on the true positives. So as a conclusion, the proposed hierarchical engine outperforms isolated approaches, and it combines the speed of expert rules with the accuracy of LLMs, and it reduces computational costs via layered filtering. So we achieved 96% accuracy in our tests, and we found it to be 8.5 times faster than LLM-only approach. Yeah, that was it. Thank you.
Thank you so much for your presentation. Are there any questions? I guess not. So I think we can continue with the next presentation then. So it's titled Enhancing Stock Market Predictions, the Role of Feature Selection Techniques in Financial Modeling.
Okay, let me share my screen real quick.
Humberto, yes, presenting.
Can you all see?
Yes, we can see your presentation.
Okay.
Please continue.
So, welcome everyone to my presentation at ICCSA 2025. My name is Humberto, and I'm really glad to be here presenting to you our research entitled Enhancing Stock Market Predictions, the Role of Feature Selection Techniques in Financial Modeling. This research was conducted by me, Humberto Bragança, and my colleagues Rafael Berri, Eduardo Borges, Bruno Dalmaso, Richard Pinto, Giancarlo Luca, Fabian Cardoso, and Viviane de Matos. We are from FURG, which stands for Universidade Federal do Rio Grande. As we know, financial market is highly dynamic and influenced by a vast number of variables. So to predict a model in this area is really challenging. This research is part of an effort to increase the performance and reliability of these models by applying different feature selection techniques. This presentation, we are going to dive deep in the methodology, the results, the conclusions, and the key insights that we had throughout it. So the agenda, we're going to talk about the technical analysis indicators, the feature selection, the methodology, then results, and then conclusion. So, technical analysis indicators. We used two different types of technical analysis indicators, the trend indicators and the overbought and oversold indicators. The trend indicators that we used were the moving average and the standard deviation, and the overbought and oversold indicators that we used were the MACD, which stands for moving average convergence divergent, and from that we generated another indicators such as MACD signal, VSDME12 and VSDME26, which stands for volatility and speed divergence moving average, MACD slope, and MACD histogram, and also RSI, which stands for relative strength index. The methodology. We used a data set called BovDB, which is a data set containing all the data from all the stocks listed in Brazilian financial market from 1995 up until 2020. We selected all the data of the 7 main companies during 2010 to 2020. And from that, we manipulated this data to generate those financial market indicators in different trading windows, periods of trading windows of different type of prices, such as opening, closing, etc. Later, I'm going to present you a table that better explains that. And each one was used as features for our model. In total, we got 194 features. And from that, we performed different feature selection techniques. We performed 7 ranking feature selections and 1 feature selection that generated a subset. We are going to talk more initially about the 7 ranking, and then later we're going to talk about the subset feature selection. So the 7 feature selection ranking methods. Each one generated a ranking that goes from the most important feature to the least important feature. For each method, we removed the features from the least important up until the most important. At each feature removal, we used cross-validation with random forest and saved the metrics, the accuracy of the models. And we repeated that for all the 7 ranking methods. And about the labels, we had stability, descent, sharp descent, rise, and sharp rise. So this is the table that better explains how the features were generated. So for example, the moving average of the opening was using 5 trading windows is one feature. The standard deviation of the max using 10 trading windows is another feature. So some of these indicators, we didn't use different trading windows because to generate those indicators, we used pre-established values for those trading windows, which explains why there isn't another values here. This table better explains how the 194 features were developed. The labels. So the descent is a drop of 0.5% up to 0.9%. Sharp descent is a drop of 1% or more. The same goes for rise and sharp rise, but it's an increase in the value of the stock. And stability is a variation less than 0.5%, both up or down. So these are the graphs that we built from the feature removal. Let's take, for example, the information gain. We started with 194 features and kept removing them from the least important up until the most important. After that, we analyzed the graph and marked with an orange dot where the model achieved the max accuracy. Here in this case, the max accuracy is 0.493798. And we kept removing the features and marked with a green dot a point where if we keep removing the features from there, the accuracy of the models will decrease drastically. So as you can see here, after the green dot, we kept removing the features, but the accuracy dropped drastically. So this means to us that for this feature selection technique, these are the key features to this model. In this case, the green dot got an accuracy of 0.483035. The same was done for the 7 ranking features: the relief, the symmetrical uncertain, the gain ratio, the MRMR, the 1R, and the Pearson correlation. Some of them got the green dot and orange dot shorter closer to each other and some of them more apart of each other. Now we have a graph that shows a comparison of feature removal of all methods. So as we can see, all the feature selection techniques could increase the accuracy of the models up until a certain point, but after that it started to decrease. Some of them started to decrease earlier, such as the gain ratio here, as we can see, and some of them delayed the drop of the accuracy. Here we have the 1R that stands out here for delaying the most the drop of the accuracy of these models. Another feature selection technique that stood out was the relief method, achieving the max accuracy here in the stage. It's important to say that here we used cross-validation without certification. So this is another step of our research. Let's take, for example, here the MR method. We took the subset of features used here in the orange dot, and from that we performed cross-validation. And from the model built using stratified cross-validation, it's important to say, now we used stratified cross-validation. And from the model built from the stratified cross-validation, we performed it in the test data set. Here in this graph, the darker colors represent the accuracy in the stratified cross-validation, and the lighter colors represent the accuracy of the model built from the stratified cross-validation in the test data set. At the top of each bar representing the accuracy of the stratified cross-validation, we have a line that represents 2 standard deviation above and below the average of their standard deviation, the standard stratified cross-validation. It represents to us that 95% of the time, the accuracy of the stratified cross-validation will fall between this range. In a moment, please. So continuing, as we can see here, all the feature selection techniques could generalize well. And here we have the CFS subset 20 using 25 features. I'm sorry, my voice is not good. I'm a little bit sick here in Brazil. With only 25 features, it achieved an accuracy of 0.49. And another model that stood out was the MR. With only 98 features, it achieved an accuracy of 0.52. This model is important to clarify that it generated a subset of features, different of the ranking features. It used Pearson correlation for that and calculation the relation between the already selected methods, which is different from the Pearson correlation that we used here, that only measured the Pearson correlation between the feature and the output. This is a table. These are 2 tables that better represent to us how each feature selection technique performed in the orange dot here and performed in the green dot. So let's analyze the orange dot table. Here, let's take, for example, the MR. Using only 98 features, it got an accuracy of 0.488 in the cross-validation without stratification. And using the same 98 features, we performed stratified cross-validation. And we achieved an accuracy of 0.487. The model built from the stratified cross-validation, we performed it in the test data set, and it achieved an accuracy of 0.519 and a phone score of 0.520. Another method that stood out here is the relief method. With only 73 features, it achieved an accuracy of 0.515 in the test data set. Here in the green dot, we have a model that feature selection technique that stood out, which is the 1R, using only 21 features. it achieved an accuracy of 0.477 in the test data set, and F1 score of 0.479. Another method that stood out was the information game. With only 38 features, it achieved an accuracy of 0.5. Remember, initially we started with 194. Now we are talking about 21 features, talking about 38 features, which is a huge decrease of number of features. So in this table, we present the top 10 features with the best average results. We took in consideration only the 7 ranking feature selection techniques, because the CFS, the subset feature selection, it generated a subset. So we couldn't analyze the rest of the features that it didn't include in the subset. So we only took the 7 ranking feature selections. We average the position of each feature using all the 7 methods and built this ranking. As we can see here, the technical analysis indicator that stood out was the standard deviation. Using 90 trading windows, it occupied the top 7 of the top 10. The last 3 were occupied by the standard deviation using 60 trading windows. The 2 type of prices that most appeared were the offer sell, the offer buy, and the opening. So this showed to us that long-term volatility is really important for the prediction of the market. So conclusions. We investigated the impact of attribute selection techniques on price prediction in Brazilian financial market. We used 194 features with cross-validation and random forest. The MR method achieved the best performance, an accuracy of 0.519, using only 98 attributes, less than half of the original total. It balanced relevance and non-redundancy considering the interactions between attributes. The relief achieved an accuracy of 0.515 with only 73 attributes, and the 1R achieved an accuracy of 0.477 with only 21 attributes. The indicators based on the 90-day standard deviation were the most relevant. They highlighted the importance of long-term volatility in prediction, as I said earlier, and it's useful in different selection techniques, enforcing their relevance in the financial market. Recommendations: for maximum accuracy, the MR. For computational efficiency, 1R. For balance between both, relief. Future research, we should explore the application of the selection attributes to more advanced machine learning models, such as deep neural networks, in order to assess whether these methods maintain or improve the observed performance. The reference of the above DB, which is the data that we used, is this one. And thank you so much. And I'm sorry for coughing and stopping so much for the water, but my voice disappeared. Thank you so much.
Hi, Umberto. Don't worry. We understand when you don't feel well and you have to present. It was very interesting presentation, study work about this machine learning technique. It's not my field, so I will ask if there is any question in the room. Yes?
Can you hear me?
Yeah, I can hear, as I said.
Okay. Can you hear me better now? Okay. Congratulations, Umberto, fellow Brazilian here. Just a quick question. It's also not my field, so it might be, but it might not make sense. But out of curiosity, have you done any exercise to try to combine multiple feature selection algorithms in order to try and come up with like a result that is more accurate?
So to be honest, I didn't combine different feature selection techniques but we have some feature selection techniques that they are similar and try to advance in comparison to another one. So let's take, for example, we used information gain, which is based on the amount of information that you can gain from that attribute about the output. So it doesn't take in consideration the features that are already selected. We have the mutual information, which works the same. And we have the MR, which uses mutual information to see the relationship between this specific feature with the output, but also measures the mutual information between this specific feature with the features that were already selected. So we didn't combine different feature selection techniques, but some of them were kind of complementary, let's say like that. I don't know if I was clear in my answer, or if you have more question, I'm really into to answer it.
Yes.
Yeah.
Can.
Sorry, I went back to my place. Yeah, it was clear. So apparently there are some redundancy between these different techniques, and there might not make any sense to combine them. Yeah, that's clear. Thank you.
Thank you
My
for
pleasure.
your question.
Any more questions?
No. Good.
Thank you so much.
Thank you. Thank you, Umberto. Thank you very much. So we move to the next presentation, that is improving anomaly detection in network traffic using based feature engineer for random forest and XGBoost model. Giancarlo Luca, Denner Aires, Bruno. Is there anyone?
It's me, Abel.
Yep.
So I'm going to share my screen.
Okay.
Can you see it?
Yes.
Is it in full screen or?
It's not full screen, but you can read. Yes, we
That's
can
better.
follow you. Yes.
Oh, okay. So hello, my name is Abreu. I'm from FURG, as Humberto, and my work is improving anomaly detection in natural traffic using showcase-based feature engineering for random forest and XGBoost models. So here's a summary of my presentation. We have an introduction, some concepts and some results, and then the discussion and conclusion of the results. So the introduction. In our contemporary society, everybody is highly dependent on computer networks. So basically everything works around the network traffic, as banking, healthcare services, and business services as well. So I have some data here that the traffic grew around 17% in 2024, according to Cloudflare. So, of course, increasing the traffic increases the threats around it, like the DOS attacks and data leaks attacks and other type of attacks. So our challenge here is to improve the anomaly detection in data to improve the detection of the DOS attacks. So here are our main objectives, which is creating a new feature with generalized Showcase integral, evaluate the impact of the model's random forest and XGBoost using this new feature, and increase the accuracy, recall, and to detect DOS hook attacks using this methodology. So here are some of the related work that we get to this paper. So which was some works about the DDoS detection using random forest SVM and PACO XGBoost, some hybrid models, some fuzzy C-means clustering for detecting anomalies. And the main gap that we get that is that no studies are using Choquet or any type of model of Choquet to detect this type of anomaly. So here's the data set that we used, which was CTDOS 2029, which is a data set from the University of New Brunswick in Canada. And it has diverse features as duration, packet count, bytes, and any other types of data and features. So to choose which ones we are going to use in this work, we use the algorithm called KBEST, which is an algorithm for feature selection. And after you use this algorithm with a parameter of 4 features, we achieve those features you can see right here in the right side. So after that, we have the conceptual model. So how does our work happen? So first we get the data, and then we preprocess, removing some empty places and stuff like that. And then we apply the K-best algorithm to select the 4 best features. After that, we apply the Choquet integral in the best feature selected by the K-best algorithm. After that, we integrate this new feature with the selected ones, and we apply machine learning algorithms that we talked before, which was the XGBoost and the random forest, uh, with the data set, with the new feature and without the new feature, obtaining some results, and which we are going to see right now. So here's the Choquet integral. So it is a powerful aggregation tool based on fuzzy measures and generalized through copulas for enhanced flexibility and allows capturing nonlinear dependencies. So when we're applying to a feature, uh, it helps the feature to be more readable. So here are the hyperparameters used in the algorithm of the random forest. And here are the results. So by analyzing the results, you can see that the accuracy, the recall, and the F1 score increases. So the accuracy increased to 59%, which is good because the main accuracy is almost 100, and the recall improved a lot, 37%, which means that our model is more assertive, and the F1 score increased 16%, uh, which means that we have less actually false negatives. And for the XGBoost, we have the hyperparameters too here, and as well as the results. So it was really close to each other. So it increases a little bit of accuracy. The recall and the F1 score has a good improvement. And as I said before, it increases the assertivity and the precision. So our conclusion is that the new Choquet feature reduces the false negatives and improves recall performance as well the accuracy. And our main contribution of this work is using the feature engineering with Choquet to improve the DTOS detection algorithms that we use, which was the XGBoost and the random forest. For future work, we are going to explore the Choquet integral feature in other kind of data sets. And that's it. I'd like to thank you, FAPERGS and CNPq, and I'm open for questions. Hello, can you hear me?
Sim, eu acho que eles não estão no local. Chegaram agora.
Hi, Amar. Can you hear me?
Yes.
Abra? Okay. Thank you for your presentation. Okay, it's not my field of investigation, so it's very difficult for me to follow some aspect that. And I'm the technical assistant actually. So I will ask to the audience if there is any question about. No, no question. Okay, and in the room, virtual room. No? Okay. So thank you, Abra.
Thank you so much.
And so we move to Mateus or Wallace Kasaka, the machine learning based solar radiation forecasting for green hydrogen production.
Hello, it's me presenting.
Hi. The
Mateus.
floor is yours.
So, good morning. I'm going to present my screen. So, okay. So my work is titled Machine Learning-Based Solar Radiation Forecasting for Green Hydrogen Production. I developed this work with Wallace Kazaka, and we developed it with the University of São Paulo ICMC Center for Research in Mathematics and Computer Science. So the outline of my presentation, I'll begin with a little context of the problem that I'm going to present. Then I'm going to share a little of the objectives, the methodology, the approach we work in this project. So the data sources, the data preprocessing, and exploratory data analysis, modeling used, modeling techniques used, and results, conclusion, and next steps. So the context of this work is basically climate change. We have global commitments since the COP23 of limiting global warming to 1.5 degrees Celsius through decarbonization. So to achieve this, it's crucial that the countries follow an energy transition, and this transition involves significantly increasing the use of renewable energy sources in the energy sources and development of techniques, for example, like the production of green hydrogen. So a key challenge for this problem is the natural variability of the renewable energy sources, data, so solar and wind, for example. And it gives some problems, for example, for the grid, for the predictability of the power output. And our proposed solution is to apply machine learning to forecast green hydrogen production, basing the technique on the prediction of global solar radiation. And it's a work with a regional focus, so we're going to work in based on Ceará, it's a state in Brazil data. So our general objective is to develop and compare predictive models for solar radiation as a basis for estimating the production of green hydrogen. And as specific objectives, we will review a recent forecasting approach, so literature review, automate data collection for this four location, analyze data to identify patterns, trends, and development models, and optimize it using random search. and compare the model's performance and evaluate the extrapolation of the optimized hyperparameter to other places, to other sites. So this is a brief a diagram of the methodology we proposed. So we began with the literature review and the understanding of the problem, and we go to a interactive part of the approach that is like after the data collection, we we go to an interactive part of data preprocessing, exploratory data analysis, and the modeling itself. So after this interactive part, after the modeling is okay, we go to the evaluation and our final results. So the data sources used in this work is data from the INMET, so it's Brazil's National Institute of Meteorology. So we used data from automatic weather stations from INMET. The collected period is it was 9 years for 16 automatic stations in Ceará, so it's a state in Brazil. And we selected the four best stations for modeling and duration of time of 4 years also. The selection criteria was basically data coverage. So from these 16 stations, there were some stations that the data was very bad. And to propose our method, we selected the four better stations. So we went to the classic data preprocessing step, a series of steps actually. So normalization and rate index and data sanitization, so very preliminary data preprocessing. And we went to initial imputation of missing values. We used mostly highly correlated variables, as you can see in figure 5. So some variables we had from the automatic station were highly correlated. For example, maximum and minimum variable for the same physical feature. And then we went to an outlier removal step. We used methods like Discord and IQR, as you can see in figure 6. And a final imputation of missing values with a methodology we proposed. So we had some missing values that after the outlier removal, and we divided in 4 cases. So for gaps greater than 24 hours, we used an imputation using the average on the same day. For gaps below 6 hours, we use interpolation. And for gaps between 6 hours and 24 hours, we divide it in two. So without seasonality, we use the simple interpolation. And for variables with seasonality, we use an average imputation. So we evaluated the following models to evaluate the best results. So we began with classical statistical models like Sarima X, just to benchmark. And after we used also classic machine learning techniques like KNN and SVR. Some ensemble techniques like random forest regressor and XGBoost that achieved very good results. And one deep learning approach, so LSTM, which is a deep learning approach that is very good to capture the long-term temporal dependencies of the data. So still in the modeling phase, we took some pre-processing steps after defining the model. So we did a min-max scaling just to give better model convergence. Then we applied a technique called time delay embedding. So is a time series analysis technique that we transform a series of time series in in more features, so create features that represent lagged observations from the original feature. So this schema right here exemplifies what this technique is about. And then we go to a feature selection step. So we selected the top 40 most relevant features after the time delay embedding. So the time delay embedding generates a lot of features, and then we selected the 40 most important. So we executed a hyperparameter optimization using random search, and as validation strategy for the random search, we used the time series cross validation with time series split. So there's a method just to preserve the chronological order of the observation and prevent data leakage, because the time series is one step depends on the previous step, so we cannot use another type of validation strategy. So for the production of hydrogen production itself, the physical modeling is based on these governing equations. So we have a first part of photovoltaic energy generation. Here is just simplified, but we have the global horizontal irradiance. That is the variable we predicted with the machine learning techniques. So it enters as input for the photovoltaic energy generation. And then this energy generation ends more or less as an input for the hydrogen output for the hydrogen generation. So we use the efficiency data for the photovoltaic module from a model of Canadian Solar, and for the electrolyzer from Siemens Energy, a model called Electrolyzer 300. So here's our first results. So it's just an example for the for the city of Sobral station, and we see it's for the XGBoost model. We see we have a, a good prediction for with these analyzed. It's just an example, but here we have the results summarized. We clearly see that for all sites and all aerometric analyzed, the XGBoost achieved the better results. So it's a very performant model, not only in predicting, but also in computational cost. And as a conclusion and next steps, we had an overall high performance for all the methods used. So R2 greater than 0.9, and the other error metrics good also. But the best model was XGBoost, not only best performance, but reasonable optimization time with the random search. And suggestion for future work related to this work is the enhancement of the LSTM technique. So with the literature review, we see that a lot of work is being done with LSTMs in this kind of problem. So it's very impressive, the results, and we believe that putting more effort in enhancing the LSTM architecture, we could have better performance in this model specifically, and also an expansion on the validation methods. So we plan to get this approach to different sites with other climate characteristics. So the four sites we've chosen is are very close to each other, and then good exercises to find other sites and see if we can also extrapolate the hyperparameter parameters with not very important loss of precision. So that was it. Thank you for your attention. If you have any question.
Thank you, Mateus. Do you have any question? No. Thank you very much. Is there any question from the room for the audience online? I have a question. Do you have in mind to do that this kind of application could be applied in different contexts? So for different analysis, which are the subjects that are suitable to apply this kind of technique?
Actually, this technique is not specific to the problem, for example, of energy generation and solar energy generation. So it's a more broadly time series approach. So I think we can extend to any time series problem, or as this problem is about set of time series. It's not very so like some steps were very related to this problem. I think mostly in the preparation, the data preparation part, because it's a physical problem actually. So there are some constraints we have to take into account. We cannot to sanitize the data, like for example the time of the day. So this kind of physical problems, and also the part of the modeling of the system itself. But actually, the prediction itself is time series prediction. So if we can normally extrapolate to other time series problems.
Okay, I get it. I get it. Thank you, Mateus.
Thank
So we
you.
move to the next the last presenter, mobile Pro testing free.
Hello, you can see.
Mateus, I think that you have to stop to present.
Okay.
Okay. So.
Hello, good morning, everyone. My name is Jorge Andrés Romero, an engineer, and it is a pleasure to be your speaker today, together with my colleagues Danilo Martinez, Mireia Zapata, and Xavi Fore. The researchers are from following university, the Universidad de las Fuerzas Armadas of Quito, Ecuador, University Technological Indo-American of Ecuador, and Technical University of Madrid, Spain. We have developed Mobile Test Pro, a testing framework specially designed to address the unique challenge of testing in mobile application. In today's mobile development landscape, where quality and user experience are essential. Mobile Test Pro aims to offer a structured and efficient approach to ensure robust, reliable, and user-friendly mobile application. Before introducing the solution proposed by Mobile Test Pro, it's important to understand the current methodological limitation in mobile development. We will not explore three case aspects that justify the needs for a new approach: the local specific methodologies, the absence of comprehensive testing tools, and the limited adaptation of the particularities of mobile environment. Okay. So this issue clearly reflect with mobile app development requires special attention, as shown there is a lack of dedication methodologies, a limited theoretical foundation in the literature, and an absence of recognized testing approach. As a result, traditional development process are still used in professional practice, even though they do not align when with the specific characteristic of the mobile environment. Okay, solution approach. To address this limitation, we propose a solution based on the Agile methodology specifically focused on mobile development. Our goal is to respond quickly to basic quality needs, allowing early identification of incorrect, undesired, or not complicated behaviors within the app. Solution approach characteristic. We developing mobile application, it is essential to consider a set of capabilities that responds to unique challenge of the mobile environment. Here we present each case proposed capabilities. Compatibility, work offline or within limited bandwidth. Interoperability, smooth communication between internal and external apps via APIs. Flexibility, adapt to user preference and environment conditional. Brightness, connectivity, battery, energy efficient, minimize battery consumption by optimizing process and connection, device heterogeneity, conscious performance across a range of device and compatibility with various sensors. Platforms delivery a common experience for user on different operating systems, and data security, protection against threats, user errors, and device vulnerabilities. The proposed solution. The proposed frameworks consist of three blocks. The first block groups development activities that produce delivery which can be evaluated to identify defects. These include activities related to requirements, design, and construction. The second block include the tools suggested for evaluating the outputs of these development activities. Finally, we incorporate mobile utilities. Okay. Our proposal combines tools for evaluating areas such as consistency, security, compatibility, and strength with development activities and mobile capabilities. To assess the feasibility of the framework, a toy application was used. The results revealed situation where the app behavior was not spent and how those issues relate to specific mobile capabilities. The main contribution of this work is to guide app developers in evaluation application and improve their quality. Okay. The process flow behind with the selection of the artifacts to be tested, which may be outputs from requirements, design, or development activities. During the initiation phase, we identify quality standards, potential risk, and protect requirements. In the planning phase, we define the test plan for iteration to ensure compliance with expense quality levels. The design phase includes preparing test case and resource to ensure readiness and optimization. The execution phase runs and monitor tests to verify whether the software meets accepted criteria and quality standards. Finally, the closure phase consolidate and communicate results, metrics, and insight gained from the testing process. Okay. Proposed solution. To evaluate the feasibility of proposed framework at Tic-Tac-Toe app development by computer science students at Ecuadorian University was used. The evaluation includes compatibility stress, accessibility, energy composition, and security testing. The application has Android 12 available on various free simulators was used. The results are present in the follow section. Results. Compatibility test. Tests of three devices with varying CPU, storage, and RAM specs on Motorola Nexus 6 and LG Nexus 5. The APK installed failed due SDK version mismatch requirement 26 instead of 25. Result app compatibility only with SDK 26 or higher. Old version may fail without proper updates. Stress testing in AutoClicker. AutoClicker was used to simulate high-frequency app usage, failed and performance bottlenecks were detected, especially related to flexibility and interoperability. Tests on physical device running Android 12. Three variations: 3 minutes low stress pace, 6 minutes high stress, 200 microseconds cycle execution failed, 9 minutes moderate continuous pace. The other test, accessibility testing. Google Assistant Scanner on Android 6 was used. Finding included small touch targets, poor contrast, missing labels, main screen, no issues, second screen, one element like an accessibility label. Energy computation testing. Aqua battery on Android 7 measure energy use over 5, 10, and 50 minutes. Results showing minimal and stable energy. Suggest the app is well optimized, support good battery life without as X. Security testing. USB debugging enable risk of data access, accessibility backups, info extraction risk, use of update system version, recommendation update to Android 10, disable debugging and restrict backup the access. The table shows that all mobile entities are linked to at least one test activity within the framework, except for connection, as the bullet app did not require internet access. However, it's important in real app is acknowledged. The framework focuses on construction activity resulting in a prototype compatibility and security issues were identified in Android version below 10 and SDK version below 25, impacting device heterogeneity and data security. Stress tests show performance under normal conditions but failure under extreme load. Accessibility tests relieve missing labels and duplicate elements. Real user testing is recommended. Energy use remain low, a stable indication good design. However, security tests reveal risks such as activity debugging and access backups, potentially compromising user data. Conclusion. Based on mobile capabilities, when propose an evaluate framework to give developers in conduction speciality tests aim at improving mobile app quality. We have proposed a framework for app evaluation, suggesting various tests related to mobile abilities. Its feasibility was assessed by applying it to a toy app development by software engineering students. Following the framework guidelines, 5 tests were conducted using different tools, revealing certainly difference in the apps. The main contribution of this work is to guide to developments in evaluate their apps and helping improve their quality. In addition, the relationship between mobilities and testing activities is present. As future works, more complex tests can be added, such as equilibrium partitioning, decision tables, mutating testing, and validation of proper app function with any testing technologies as needed. We also suggest implementing automated usability testing using tools like Expresso and Appium to identify issues in the user flow. To optimize accessibility testing, tools such as Axe for Android could be integrated. Security assessment could be enhanced with static and dynamic analysis tools like SonarCube or WhatsApp for deeper vulnerabilities detection. Connectivity testing should also be included. Finally, the framework should be validated using a real-world app by definition efficiently and user satisfaction metrics to compare it against other testing approach and support software improvement. Thank you for your attention. I now open the floor for any question, comments, or suggestion you may wish to share. I will be happy to respond and elaborate on any part of the presentation.
Hi, Andres. Thank you for your presentation. Was very well structured. And do you have any comments or
No question.
no question? No, no question from the presence. And is there any question from the virtual audience? No. Okay. Thank you, Andres. So the session we can close the session. Thank you everybody for joining us in the room, and so have a nice day.
Thank you so
Okay,
much.
but once again, thank you very much for your time and attention. It has been a pleasure to share this proposal with you. I hope the information presented was valuable. Thank you.
Thank you
very
so
much.
much. Thank you so much.
Thank you. Thank you very much.
Thank you.
Thank you. See you next occasion.